Raise your hand if you have the BCE. All right. I'll let you guys continue. We're not here Friday. I'm holding you responsible for the news. Very long. We did like a video and it was 3 different examples. So I'm asking you to know that. So guys, tell me what you wrote for your reactants and products. Spell it out for me. Okay, and then you probably, I saw some of you guys put little plus and minus. Don't forget hydroxide is the whole shebang. Happy family, don't be homewrecker. And what else? CO, OH, parentheses 2, right? Why? Cobalt has a 2. Please put your parentheses. If you just put the 2 on the outside without parentheses, that only applies to H and not OH. I saw a couple of those. That will be the death of you. Okay, next. Na 1 plus, Cl 1 minus, crisscross 1 1. All right, balance. Is it good? No, it's not good. Sodium hydroxide, I heard it. And what else? And the sodium fluoride. Good, because you need 2 OHs, 2 OHs. That makes 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines. Woo! Okay, so we've only done step 1. Balance chemical equation. Second thing you had to do is what? Hold on, we haven't even decided who's separatable. Determine the solubility. So, determining solubility means you got your solubility chart out. There's probably one nearby. If there's not one nearby, make sure everybody has one like somewhat in front of them. Okay, so fluorides. Tell me the general solubility of fluorides. Soluble is cobalt an exception to the soluble rule. Nope, so it's still soluble. You get this on your test, so please make sure you know how to read this. Sodium hydroxide. Hydroxides? Insoluble, right? What are the exceptions? And what else? Alkali metals. What does that mean?
Anything group 1.
Group 1A. So if most hydroxides are insoluble, immediately you're going to precipitate. But this is an exception, so what do you say? Aqueous, right? Because this is telling you that yeah, most hydroxides are going to be insoluble or precipitates, but group 1A metals, aka sodium, is going to be happy and it will be soluble. Next hydroxide over here. Insoluble because all hydroxides are insoluble and cobalt is not an exception, so it's still insoluble. Chlorides. Say again. Soluble. And sodium is group 1. Anything with group 1 metals are always soluble. Okay, so now we got our solubility. Third step. That's when you do what you said earlier. Right. And let's go ahead and square off the ones that are not going to ionize. So which ones are going to ionize? Anything that's what? Soluble. Anything that's aqueous. So check. This one? No. I'm going to put a box around it to remind you that we do not ionize it. And then yes, you ionize the last one. So only things that are AQ are ionizable. So if it's a solid, if it's a precipitate, if it's a gas, if it's a pure liquid, you cannot ionize them. Okay, so then break this up into the 2 components with their charges, with their ion charges. CO2 plus and how many Cl's are there? 2 of them, right? That subscript means there's 2 chloride ions, 2 Cl1 minuses. And then this one, 2, yeah, that 2 plus there. Na what? 1 plus, right? The sodium is a 1 plus charge. Because you have to, I know you're uncrisscrossing, you're giving the 2 back to cobalt, but this compound tells me that I have 2 chlorines in it. So when I ionize them, I'm going to make or produce 2 chlorines or 2 chlorides. Even though, yeah, you're giving the charge back. That makes sense though, because all ionic things are electrically neutral. So a cobalt with a 2 plus charge and 2 chloride ions, what's their total charge together? 0. So that makes sense that there's 2 of them because they always come out to be neutral. Okay, so sodium 1 plus, and then what? Yep, that 2 goes there too. 2 what? Hydroxides with a negative 1 charge. Okay, next. Say again? Same. Keep it the same. CO, CO or OH2. I'm going to put precipitate, and what happens here? 2Na plus 1s and minus 1s. Okay, so this is called the complete ionic equation because it has completely everything that ionizes as an ion form. Ions have charges, so you have to pay attention to those charges. All right, and then so what are that term spectator ion came into play last week? Yeah.
Yeah, would that be the cobalt hydroxide?
So tell me what spectators do at like a sporting event. They watch. They don't play, right? So in this reaction, in this game, the reaction is the game. Okay, it's making something that's the game. The spectators are not playing in the game because they're not doing anything to make something happen. So what's actually happening in this reaction? What kind of type of chemical change is happening? What's happening? Right. So who is making this happen? We know cobalt is and hydroxide is. So this is player 1, this is player 2, and they make the game happen. Okay? The other ones are all spectator ions, but we have to be very careful to make sure spectator ions don't change, right? They, from the beginning of the game to the end of the game, they're still sitting in the stands, eating popcorn, that's it. Okay? So they have to be exactly the same. Sometimes they will not be exactly the same, but this one they are. So who are the spectators? So 2 sodium 1 pluses, 2 sodium 1 pluses, they have to be exactly the same. And then what else? 2 Cl1 minuses, 2 Cl1 minuses. You can actually see who the players are before this, but I want to make sure you have a process because you'll get caught up on something that maybe it's not as easy. So then all you do is rewrite it. This stayed, so cobalt 2 plus stayed, 2 hydroxide stayed, and they made this game. They made this cobalt 2 hydroxide form. So this right here, this final thing, is called the NIE, net ionic equation. It's not hard, it's just kind of lengthy. That's my opinion. So, I'm going to do one more, but with a single replacement reaction. And this is on the lab. So, we're going to do 2 labs. We're going to do types of reactions lab, and we're going to do net ionic equations lab. It's fun, you get to see the different precipitates, it's really pretty. But before we do that, oh, don't look! No! Close your eyes! I didn't erase this. Okay, we're gonna do number 5. So okay, actually looking at 1, 2, and 3, what kind of reactions are those? No. Don't guess, people, don't guess. Look at 1 and 3. 1 through 3. So you see ionic compound plus ionic compound, they have to switch places, right? Same. Number 4 and 5, this one says zinc and hydrochloric acid. This one says copper and silver nitrate. So those are single replacements. So we're going to do an NIE for a single replacement, which I think is a little bit more tricky. It's not hard, it's just you got to pay attention. So tell me what I'm writing. Write this down too. This is number 5 on the lab. If you want to write at the bottom of the lab right now, I'm doing number 5 for you. Okay, so I know you can get at least a 20% on this lab, so I'm doing 1 of 5 for you. Woo! Cu, Ag, and O3. Good. You know silver's charge is 1. Okay, then what are you considering right now? Can copper replace Ag? What are you looking at? Activity series. Yes. Right. Well, look, copper is really low. Where's silver at?
Even lower.
Even lower. It's like 2 below it, right?
It's like one of it's like there's AG.
Right. So they're still very low, but copper is still above. So yes, this will happen. Yes, this will switch places. And what does it make? Assuming okay, plus Ag. I want you to assume copper is, so copper comes in 2 varieties, plus 1 and plus 2. Generally, copper 2 forms. So if I'm telling you this is copper 2, what does this look like over here? NO3 2. Okay? Balance me. Balance.
So you need 2 in front of copper on the left, right?
See 2 nitrates here, so I need 2 nitrates. So put a 2 here. 2 and Ag here. Is that it? Is that it? Good? Yeah. Okay. This one I want you to label the states of matter. Pure copper. Solid, because it's a metal. Solids are metal at room temperature. This is probably a solution of aqueous silver nitrate, and I would tell that to you in the problem, so I'll just tell you that now. That's aqueous. Another solution is formed. This is also aqueous. I'm running out of space. There we go. Silver Solid. Okay, so visually, what would it be happening? What kind of color changes would you be seeing? What would you be seeing in this reaction? Beautiful copper, right? It's copper in color. Huh? Silvery color, right? You'd see the formation of silver from copper. Crazy. And then this is a clear solution. Do we remember what copper 2 is? Copper 2 is color? Blue, you know, close. So you just gotta remember copper 2 is blue. It rhymes. Okay? Copper 2 is blue. Copper 2 is blue. So it does make a blue color, so you'll see that form as well. Oh yeah, you guys haven't done the other lab. That's why I was like, do you remember? But you haven't done the lab yet. Okay, so now we go to BCE. We just talked about the observations you'd make. Tell me what the NIE would be. First, block off the things that are not aqueous that you will not touch.
Copper.
Okay, copper stays and silver stays. You do not make them an ion. They are not ions. They are solids. So write that again. Copper solid plus, does this break down? Yes. All nitrates are soluble. Go. What did it break down to? Ag 1 plus, you say so hesitantly, but you are correct. Plus. How many of them? Right, this 2 applies to both silver and nitrate. So 2 nitrates, NO3, 1 minuses. Okay, cool. And this does break down. All nitrates are soluble. 2 plus, yep, because that 2 is copper's charge. NO3, 1 minuses, and 2 Ag plus, 2 Ag solids. Okay, so now, what are the ions or compounds that are exactly the same on either side? 2 nitrates, I see that. 2 nitrates, 1 minus charge, 2 nitrate, 1 minus charge. Good. You got to really pay attention. This one's got a 1 plus charge. This one doesn't have any charges. So this is an ion, which I can't see. It's just embedded in the solution. You can't see it. This is a big plop of solid silver. Totally different things. This one is like beautiful copper, pretty color. This one's like a blue ion. Totally not the same thing. So that's why this is it. You only cancel 1. You rewrite copper solid plus 2 silver ions yields copper 2 ion and 2 silver solids. This is the NIE on this one. Single replacements just are they're just a little different. That's all. I just want to make sure you know how to do that. Yeah. Because they are not the same. There's actually a reaction happening here. Copper and silver plus. Copper was the solid, silver was the ion, and then they traded places. Copper is the ion, silver is the solid. So they've actually exchanged electrons here. That's why one's a plus charge and one's neutral. So there is a reaction happening. It's called redox. Maybe chemistry. That's all right. You guys can do it later. So anyway, how about that lab? Yeah. Okay. So label your lab types of reactions, and then we'll do another one at the end called the replacement reactions lab. So type of reactions lab, you're going to see 4 of the 5 types of reactions. You're going to see 4 of the 5. And I just want to show you how to do 2 things before you begin. So when you're ready, just turn around back here. Alright, let me see your beautiful faces. Okay. Filter paper? Yes? What do you filter in filter paper? Stuff with stuff in it, right? Liquids with solids in it, specifically? Okay. You have to do that because I don't want any solids on the sink because I get yelled at from all the things. Okay, and then I yell at you and then I take out my anger. Great. So you fold it in half one way, hamburger and hot dog both ways, and then there's like one little triangle you fold over on itself, and it makes a bowl. Look, and the bowl fits in the funnel. And then you just pour your stuff in here and it comes out the bottom into there. Yes, we know how to filter now. Okay. Second, whenever it says get to step 5, it says to fill a quarter of the test tube with sodium bicarbonate. You're going to heat it. You're going to not put it in the flame, not touch the bottom. Okay, you're going to put it above the flame, and you're going to hold it at an angle, not towards a friend, not towards yourself, not be like, hey, is that reacting? Okay, so you want to make sure it's at an angle. But then it says to put a flaming splint, popsicle stick, inside the mouth of the test tube, about like right there. Maybe like 2 inches in there. That's it. Okay? This has to be flaming. So you're going to catch it on fire. It's going to be on fire. When the gases start evolving, you're going to put it in the presence of the gases and then make your observation. If you're not sure that you did it right, you can do it a couple more times. It's still producing gases. Other than that, please wash out your test tubes, your pipettes really well before you use them, because you don't have to use them before you go through your class. But other than that, you guys can read the lab. It's pretty easy. It's in lab notebook. Can I trust that you will choose a good group? Yes? Groups of 3. If you make a poor choice, I will dock your grade. 5. Alright guys, go ahead and read the lab first. I'm going to turn the gas on in about 2 minutes. I'm asking you to read the lab first. Start making a data table. Types of reactions. Yep, types of reactions.